Survey prep, what we need is we need to heat the building. The building, regardless of what building it is, it needs to have the fabric of the building, the construction of the building needs to be heated fully, not the air temperature inside. If we have a building that has only had its heating system switched on for an hour and all it's managed to heat up is the air inside, we end up not being able to identify these changes in temperature from inside to out, and therefore not be able to identify things like continuity of insulation or missing insulation, etc. We need to make sure that the surfaces are dry, and that includes dampness, because a surface that is in a condensative state has a warming effect. If it's in an evaporative state, it has a cooling effect. So those two states we don't want to enter into. So we want dry surfaces. We want no obstructions. We want as little obstructions as we possibly can. Now that one on its own is quite difficult when you're talking about doing an occupied homeowner who's got furniture, etc. That we have to deal with. But as far as possible, we want to have as least obstructions as we possibly can. And we want no solar radiation. This image here is a great example of how the sun has affected the surfaces of the building. The blue area on the building is because that's the shadow from the building behind it. The white areas, the red areas, and all the way down the street on every other house is just where the surface has been warmed to the extreme by the sun. So this survey will have to wait another couple of hours for that to dissipate. Once it's dissipated and it all starts to even off, then we can go ahead with our survey and look at the continuity of insulation, for example. The other thing is we quite often disregard the wind. The survey prep, we need to talk about having less than 5 meters per second wind blowing across a surface. That's 10 miles an hour, roughly. So it's not really the drone that's the controlling factor when it comes to when we carry out the service in wind. It's because a 10 mile an hour or more wind blowing over a surface will artificially cool that surface. If you combine that with wet or damp surfaces and solar radiation, effectively now with all those three things taking place, there is nothing of the heat loss from the heat coming out leaving the building that we can see. It's all, evaporative state, it's all solar radiation, or it's all wind cooling the surface. So it can be quite awkward to plan and do these types of surveys. The one thing is clear, that the best time of year to do this is between September and April. And we are already at the point in our workflow where we're having to organise heat loss surveys for later in the year, because we've got beautiful late daylight today, where this evening it could take until 9 o'clock for the solar gain to dissipate from a building surface. And that might not be a great time for the client to want to have people crawling all over their properties. So this is can be a winter job only.